Hi, my name is Tom Hoeffel, and this channel is all about learning chemistry. In this video, we're going to be talking about resonance structures. Okay? And to do resonance structures, what we're doing is we're actually blending together some of our Lewis models. And the examples that we're going to do today are going to be ozone and nitrate. And then when we're done, we're going to talk specifically about this idea of bond order. So let's get right into it. We're going to try to do the model for ozone. And if you don't know how to do some of the things I'm doing on the board, you need to go back and watch the covalent bonding, because what I'm going to do on the board right now is from that covalent bonding video. So this is kind of like an add-on to that particular video. So ozone is O3. And for O3, we got three oxygens that are each donating 6 electrons. So we got 18 electrons to work with when we're bonding ozone, or O3. Okay, so we're going to draw 3 O's. We use 4 electrons for the bonding. So we have 14 electrons left over. We're going to fill our non-central atoms octets first. So we have 2 electrons left over. We always place the leftover electrons on the central atom. And we have no electrons left over. Like I said, if you don't know how to do some of this, you need to go back and watch that covalent bonding video. Okay, but right now we're kind of in a dilemma. Okay, we have the octets fulfilled of our non-central atom, but our central atom has 2, 4, 6 electrons. And we have multiple places where we can move some electrons to make them shared so that the octet is fulfilled. Okay, we could take electrons from this oxygen, or we could take electrons from this oxygen. And when you have those options, that's typically when you have a resonance structure. So what I'm going to do is I'm going to draw the same exact thing over here, and we're going somewhere with this. So we do 3 oxygens, fulfill the non-central octets first, place the leftovers on the central atom, and we have the same thing right now. So like I said, to finish the problem, we have some options. We can take them from the left and make them shared on the left, okay? Or we could take them from the right and make them shared on the right. As you can see, the non-central atoms still have 2, 4, 6, 8, as well as my central atom. My central atom now has 2, 4, 6, 8, and whenever you have all your elements having 8 valence electrons, that's a great thing. That's when the octet rule is fulfilled. I have this saying, it's called 8 is great, like chocolate cake. So we want to have that happen, and we do the same thing on the other side. Now, understanding this is different than just completing the octets. Completing the octets is like one level of understanding chemistry, but truly understanding what resonance is a whole nother level, okay? So whenever you have these options, hey, I can do the double bond on the left or the double bond on the right, we have to put this double arrow in between. And what that double bond, what this double arrow represents is that resonance is taking place, okay? And some students really confuse like what resonance is. So in layman's terms, or in easy, straightforward fashion terms, okay, we're just going to have to blend this model and this model, but we're going to have to blend it in our head, okay? Because there's not a Lewis model that exists that truly depicts ozone well with just a single Lewis model. We're actually taking this model, and we're blending it in our head, okay? And our textbook actually has a great kind of analogy. They kind of say, hey, pretend that this ozone on the left is kind of like yellow paint, and pretend this ozone on the right is kind of like blue paint. And hopefully you know your colors well enough that when you take yellow paint and blue paint and you blend them together, okay, the color that you actually see is going to be green, okay? Now, when you look at this green color, you don't see yellow 50% of the time, and you don't see blue 50% of the time. You actually see green 100% of the time. And we have to take that same analogy to the way we view ozone, okay? We're not seeing this like 50% of the time and this 50% of the time. We're actually seeing a blend of both of those, okay, 100% of the time. So what does that mean? Well, if we're focusing in on this bond between the first oxygen and the second oxygen, some people think, oh, sometimes it's a double bond and sometimes it's a single bond. And that would be like saying, hey, some of the times I see yellow and some of the times I see blue, okay? And it's not true, okay? So we blend them together, and what actually happens when we blend them together, it's not quite a double bond, it's not quite a single bond, it's a blend or an average of those things. So what it ends up being is a bond and a half, okay? So if I was in charge of chemistry, which would be a cool thing, okay? I'm not, okay? But if I was in charge, if I blended these together, this is kind of like what I would see, okay? So here's the first bond, and then they would each kind of like have a half bond. This is kind of like a good depiction of what this Lewis model is trying to say. And you might say, well, why didn't they just do this? Okay, I would love that too, okay? But they didn't, okay? I think a part of it is, well, how many electrons would you put on this one? How many electrons would you put on this one? And that would kind of mess some things up in the Lewis model format, okay? So in the Lewis model format, we don't have this, okay? We have these two things, okay? And then we're blending them together, okay? And if you want to think about, how those bonds are occurring here as far as the order, okay? And this is where we have to come back and talk about bond order. When we're talking about bond order, if it's a single bond, we say that it has a bond, if I can spell. If it's a single bond, we say it has a bond order of 1. Okay. If it was a double bond, we would say it has a bond order of 2. A triple bond, we'd say it has a bond order of 3, etc. But if this is a bond and a half, the bond order is not any of these things. Okay. The bond order in ozone, okay, is going to be a 1.5 or 3 halves, okay? And the way you kind of can figure that out is we got 3 bonds, okay? And those 3 bonds are divvied up into 2 locations. So kind of, if you think of it as total bonds versus locations, we got 3 bonds, 1, 2, 3, 2 locations, 3 halves. So there's 1.5 bonds for each of these bonds in ozone. So that's where we come back and to do bond order. Okay, so let's kind of reverse and review kind of some of the stuff that just happened here. Okay, when we're doing our Lewis models, as far as covalent bonding, we get to a point where we could have grabbed electrons from multiple locations. We could have grabbed them from over here to make a double bond or over here to make the double bond. And the answer is you're going to have to draw both of them, but the blending has to be done in your head. So when your teacher asks you, well, what's the bond order? It's not a double bond. It's not a single bond. Okay, it's going to be a bond and a half. So the bond order is 1.5. Okay, so let's take a look at another one of these resonance structures. Okay, one that might be a little bit more challenging would be something like nitrate. It's a polyatomic ion that consists of 1 nitrogen and 3 oxygens. So let's total up the electrons. So we got 1 nitrogen that donates 5. We got 3 oxygens that donate 6. So we add this up together. You see that it adds up to 23. Whenever you get an odd number, ding, 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 you're doing something wrong. Don't forget about the charge. If this thing's a -1, that means an electron has been added to the structure. So we have 1 more. So 5 plus 18 plus 1. Okay. It's not going to give us 23, it's going to give us 24, which is an even number of electrons, which I feel good about. So let's start building this thing together, and let's see if something special happens. We have nitrogen, we're going to bond it with 3 oxygens, okay? And that's going to cost us 2, 4, 6 electrons. That means there's 18 electrons left over, 2, 4, 6, 2, 4, 6, 2, 4, 6, plus the bond gets us up to 8 to fulfill the octet rule. That means we used all the electrons, there's none left over, okay? And if you look at our nitrogen, it's not happy, okay? It only has 2, 4, 6, and it wants to have 8 valence electrons. So I have options. I could grab them from the left to share, from the right to share, or the bottom to share. So those are 3 different options. So I'm going to have 3 different Lewis models. So I'm just going to kind of redraw these. And we're going to draw double arrows in between them because they are in resonance. Okay, I could grab the electrons from this side, the electrons from this side, or the electrons from down here. Now remember, all of these are polar covalent. So when I look at nitrogen and oxygen, we have dipoles in here. We're going to put those dipoles in here just to have perfect drawings. They're going towards the oxygen because oxygen is stronger than nitrogen. Of course, we're going to put these in brackets because they're charged. Don't want to forget about that. But these guys are in resonance of each other. So this double bond really isn't just here. The double bonds are also over here, and that's what gets the nitrogen up to 8 valence electrons. So what is the bond order? Well, the total bonds are 1, 2, 3, 4. We got 4 total bonds. How many locations? We got 1, 2, 3 locations. So this comes out to being 1 1/3 as far as the bond order. Okay, I do hope this all helps you. Remember, we're blending these together, so each of these bonds is 1 1/3 throughout each of these. Okay, I hope this helps you understand resonance and how to blend molecules together. If this helps you, okay, please like and subscribe. That helps the YouTube algorithm get this information to other students that want to learn about resonance in a straightforward fashion.